Well, hello everyone. Welcome to this short educational video for A-level computer science. Without further ado, let's get this party started. Alrighty. Today we will explore object-oriented programming, one of the most powerful paradigms in modern software development. And by the end of this video, you will be able to explain the 4 pillars of object-oriented programming. That is, we've got abstraction, we've got encapsulation, we've got inheritance and polymorphism. We are going to be able to differentiate between classes and objects, apply these concepts using a real Python example, and relate everything to a real-world scenario, the cookie factory. Alright, let's begin. Okay, imagine you work in a cookie factory. The cookie cutter is going to be your class. That is, it defines the shape and the blueprint. However, be careful, it's not a cookie yet. Every cookie you make is going to be an object. Okay? An object whereby here is going to be something real, something edible, an instance created from the class. Alright? Classes now, they also define attributes like cookie color, size, or toppings. And they will also define methods such as bake, decorate, or pack. Now, with this simple analogy, we are going to understand even advanced concepts. First things first, we've got inheritance, whereby new cookie cutters based on existing ones. Secondly, you have polymorphism, whereby one action, like decorating, producing different results. And then when we're speaking about encapsulation, it's about the internal process hidden inside the oven. Now that you've activated your prior knowledge using a familiar scenario, let's move to the actual Python demo. To make these concepts concrete, my colleague Dilvesh will now walk us through a real Python implementation of the cookie factory. Hi Dilvesh, could you walk us through how to build these cookie concepts in Python?
Let's use a cookie analogy to explain classes and objects in Python. You use cookie cutters to create many cookies. In the same way, we can use a class to create many objects. So how do you write the simplest form of a class? First, we use the keyword class in lowercase. We'll name our class next. We'll call ours cookie cutter. And then we press enter. Since this is just the simplest form of a class, we'll put nothing inside. We'll just say pass. Pass means there's nothing. And that's it. That's the most simplest version of a class.
Okay, alright, so now we've got a class. Well, what can we put inside of it?
So we can keep attributes in it. Attributes are like the details about our class. And if we continue using our analogy, it's like the properties of the cookies, flavor and size. And we can keep methods. Methods are things you can do with your cookie. For example, you can bake it. So first thing first, we'll have to create a very special method called the constructor. Def init. The constructor is a very special method. It's called when we create an object from the class. And it initializes it with attributes that we specify, if any. So in this case, we have a cookie class with a constructor that has parameters for shape, size, and flavor. In all, there's one special method here named a constructor, and there are 3 attributes: shape, size, and flavor.
Alright, well, now we've created a class, we've got its attributes in it. Is that it? Have we understood it all? How can we use it now?
Yeah, basically we have a cookie cutter now. We have no cookies yet. So if we use our analogy, we need to create cookies now. And in that case, we need to create an object. How do we create an object? We'll first get out of a class, and we'll create a cookie. Let's call it cookie1. We'll say cookie1 is equal to cookie cutter. Cookie cutter is our class name. So we're using the class to create an object. The shape is star, the size is medium, and the flavor is chocolate chip. So now we have one object. If I want a second object called cookie2, here it is, and it goes on like that. I can keep on creating new objects and so on.
Yeah, we've got two cookies now, and these are based on our previous explanation. There are two objects, right, from the same constructor above. So can you tell me, is it true that we are using the same blueprint as above? Both of these?
Yeah, both of these are using the same blueprint. For example, cookie1 is coming from cookie cutter again, and cookie2 is still coming from cookie cutter.
But it's just the shape. It's just about the shape which is different.
Just the attributes that are different.
Okay.
We change the attributes for each type that we created.
And can these objects behave differently?
Yes, these objects can behave differently. If you want to create a more specialized object, you can use something named inheritance. So how does inheritance work? We create a child class from the main class. I'll create one right now. Let's call it Fancy Cookie. So Fancy Cookie is a class that I want to create from the main class that we have above named Cookie Cutter. So now I have a new type of class named Fancy Cookie from Cookie Cutter. If you can see here, the constructor adds a shape that we already have, size, flavor, and something else, decoration. So it's a new type of cookie cutter now, named Fancy Cookie.
Nice. So we've got yet another cookie cutter basically. So we've got already so many cookies now. They truly have so many different shape. And what's wow is like within a few lines of codes. But tell me something, Dilvish. How do we know that our code is working? Can you actually print something for us to see?
Yeah, we can't directly print a class or an object, but we can print the attributes from the class. Let's check out one of the classes we created on line 10. Cookie1, we created an object from the class cookie cutter. So I can print, let's say I want to print cookie1 dot, and I choose one of the attributes. For example, in this case, I choose shape, and it will print the shape from cookie1. If you can see here, cookie1 has a shape of a star, and our output is expected to be star, as you can see here. So what we did here, we accessed the object through the name of the object. We accessed the attribute that it assigned to shape, the value of the attribute, and that value was star.
Whoa, seeing your code work seems so satisfying. Well, so if I'm just let me know if I'm on the right track. So you tell me that is it okay that if I say that special cookie is reusing, well, rather Fancy Cookie here is reusing everything from the cookie class we created above?
Not exactly. Fancy Cookie is reusing most of the attributes from its parents, all of it actually, but it's adding something else. It's adding one more attribute named decoration. It's like parents and children. You look like your parent, but you might have something extra.
Hence the term inheritance.
Yes.
Okay, so yet another concept that we've learned in regards to the pillars is polymorphism. Could you guide us on that, please?
So right now, we don't have more than one method in our classes. We have only the constructor. So what we can do, we can create two different classes. Let me erase everything and we'll start all over again. Let me create a class named Soft Cookie. Soft Cookie, and it will inherit from cookie from before. So we'll get this back up. Class Soft Cookie. So this is the child of a cookie cutter. Cookie cutter. We'll add one method to it. We'll add only one method. We'll call it bake. The bake method will just print something on screen. Let's just put baking instructions. Bake at low heat. Okay, so we created one class named soft cookie from the parent named cookie cutter. Let's create another one. Let's call it class. And this one is a crunchy cookie. Okay, and this one you have to bake at high heat. So right now we have two objects, two classes that can create objects and different methods. So now if I call for soft cookie and I'm calling the method bake for crunchy cookie.
So we've got here, I see that we've got two classes, soft cookie and crunchy cookie. And now if we want to see it in action, it's quite wow, because we have got two methods with bearing the same name. However, what about the output? Will it be the same, or are we going to have two different output here? Could we try this out?
There'll be two different outputs. This is called polymorphism. We have one parent class and we created two classes from them. They both are created from the same class, and if you can see, we have an extra method for each. There's a bake method. Here, the bake method for soft cookie will bake at low heat as output, and crunchy cookie has the same bake method, but it's baking at high heat here. So we're using the same method, but depending on which child class it is, it will print different outputs. See, it's the same method, but it's behaving differently. As you can see here, bake at low heat, bake at high heat, both coming from the same method. This is called polymorphism.
But what is different is going to be the class name, right? And the attributes that you have inserted between parentheses.
Yes, but the method has the same name. It's behaving differently.
Nice. All right, so could you tell me now, guide us through what's the concept of encapsulation among the four pillars of OOP?
So encapsulation protects internal data, so it cannot be accessed directly. For example, in this code here, we have shape, we have size, and the principle of encapsulation is that we hide all sensitive data inside the class. You cannot directly access it from outside. You have to use either a get or set method to access it. For example, here, all data in this class is inside it. And if we want to create an object, like let's create an object, let's call it cookie cutter. Let's add some values to it. And let's try to access the data. So you can see the data, we accessed it. It's all hidden. That's print out from here. But if we try to access the data directly by printing this, it won't work. So that's encapsulation.
Whoa, that's pretty awesome. Thanks a lot, Dilvesh, for your time.
No problem.
All right, so to summarize, classes are our cookie cutters. Objects are the cookies itself. Attributes describe the cookie. Methods describe what it can do. Inheritance let us reuse and extend. Polymorphism, on the other hand, allows one action with different results. And then we've got encapsulation, which is going to hide all the internal complexity. Let's revisit this quickly with our cookie animation.
The cookie cutter is the class. It defines the shape and structure of cookies. It's only a blueprint, not an actual cookie. You can reuse it to make many identical objects. Each cookie made from the cutter is an object. Objects are real instances created from the class. Many cookies, one cutter. Many objects, one class. Attributes describe how each cookie looks, color, size, icing or toppings. Each object can have different attribute values. Same cutter, but cookies vary in details. Methods are what the cookie can do, be baked, decorated or packed. They define the behavior of the object. Every cookie can perform the same set of actions.
Alright, we are back again. So thank you for watching. We hope our cookie factory helped you visualize OOP in a simple real-world way. Feel free to explore by experimenting with your own classes and objects in Python. You might take it up a challenge, try other programming languages such as Java, alright, or even JavaScript. Special thanks to Dilvesh for the live coding session we had earlier on. See you guys next time. Bye bye for now.